Hello and welcome to another presentation, and actually the last presentation in the LADAL Opening Webinar Series 2021. My name is Martin Schweinberger, and together with Michael Hoare, I'm co-directing LADAL, the Language Technology and Data Analysis Laboratory in the School of Languages and Cultures at the University of Queensland in Australia. LADAL is part of the Australian text analytics platform, ATAP, and the aim of ATAP is to provide researchers with a notebook environment, in other words, a tool set that is more powerful and customizable than standard packages, while being accessible to a large number of researchers who do not have strong coding skills. Before we start, I'd like to read out an acknowledgement of country, which we do here in Australia, to express our respect and gratitude towards the Indigenous people of Australia. So I'd like to say that we as members of the University of Queensland acknowledge the traditional owners and their custodianship of the lands from which we're broadcasting this webinar. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. I'd also like to say that we recognise their valuable contributions to Australian and global society. Now, if you want to know more about LADAL and the resources we provide, please feel free to explore the LADAL website. No worries if you've missed any of our talks. Most of them are freely available on our LADAL YouTube channel. You can also find information about past and upcoming presentations, well, not upcoming now, but maybe next year, in the LADAL Opening Webinar Series 2021 on the events subpage of the LADAL website. If you want to keep up with what's going on at LADAL, please feel free to follow us on Twitter or on Facebook. And if you have any questions, suggestions, or feedback, please do not hesitate to reach out to us via email. Now, without further ado, it's my real pleasure to introduce today's speaker, Sarah King. Sarah is the Training and Engagement Lead at Australia's academic and research network provider AARNet. She has extensive expertise in engagement and training, with expertise in research data and technologies in the humanities and social sciences, plus research areas. Prior to e-research, she has worked for almost a decade at the National Archives of Australia and a few years at a public library. She has a PhD in migration studies and is a little bit obsessed with the idea of knitting as a form of coding. So it's a real pleasure to have Sarah here to tell us about AARNet and e-research infrastructures. And it's a real pleasure to hand over to Sarah.
Thank you. Thanks, Martin. I really appreciate that introduction and your invitation to join you today. I kind of have that modern day librarian skill set, I guess, where I'm really interested in the digital side of collections and the way that researchers especially can interact with collection data and text and all of those things. But I also really have a very deep and abiding dedication to the humanities and social sciences. So I'm really happy to be in a kind of at the crossroad between the two in this sort of technical translation type role. So today sounds like it might be technical, but I'm hoping it will be a good kind of welcoming and inclusive way of talking about some of the things that we might even use already, but we just don't really maybe think about in the way that technical people think about them all the time. So I work for an organization that is quite technically oriented, but my job is to do the communication side of things and talking to people to make sure that they understand what we're here to do and what we're all about. So I do have a little slide set, so I'll just set that up and then I'll share my screen. Just one moment. Okay, so can you see the correct side of the screen there?
All good, perfect.
Yeah, okay, great. So yeah, I work for AARNet. AARNet stands for Australia's Academic Research Network. And a lot of us, when we think about networks, we think about the networks between people. We might think about networking events or social networks, but when we talk about network, we talk about the network that connects people via computers, basically. So how you might access, for example, the internet. So part of what we do at AARNet is maintain and build this research network that is exclusively available to research and education providers in Australia. And on top of that, we create ways in which you can interact and make the most of that network. And so I'll be talking to you today about that network, about that platform called CloudStor, and something called SWAN, which is a service for web-based analysis, which I'll explain in more detail, and Jupyter Notebooks as well. And then finally, our involvement with the Australian Text Analytics platform. So AARNet is a not-for-profit company. It's owned by all of the universities in Australia and the CSIRO. And our main role is to provide ultra-high-speed internet and communication services to the research and education sector. You can find out more about AARNet via our website, which is aarnet.edu.au. We have lots and lots of great video content on our AARNet YouTube channel, including some how-to videos and some demonstrations from researchers on how they use our tools. And you can stay up to date with the latest on Twitter at AARNet. So one of the first things I wanted to talk about was this concept of network and connection. You can see on my t-shirt with the data connector. And what we need to do, I think, is to make sure that people understand that what you get on a university campus or in a GLAM or in other research and education type institutes is quite a different type of network to what you would be using at home or what other businesses use. So in Australia, there are a few different technologies that are used for connecting computers and the internet. One is ADSL, is ADSL Plus too, and that's what a lot of us used before the NBN, although I know in regional Australia, there's still quite a few people on an ADSL connection. The NBN is the National Broadband Network, and that continues to be rolled out. It also provides quite good connection in CBD and schools and a few other things. But what I've got to talk about is something called NREN, and I know a lot of people have never heard of that term before. So I'll explain that and then let you know just how those properties differ in these different technologies. So NREN stands for National Research and Education Network, and most countries in the world with a university system has one of these. So we're one of a global network. And what we do is we connect universities, CSIRO, some GLAM, that's galleries, libraries, archives, and museums, potentially very important holders of HAS research data, other research institutes, hospitals, and schools. So really, the main difference between any of those networks when you get to the guts of it is the speed. So you probably already noticed a little difference working from home during lockdown and so on, that your network connection at university compared to home is quite different. And there is a really sort of basic reason for that. The way that your network is set up at home or on the NBN anywhere is that you have a better download speed than you have an upload speed. So you can see on this slide, you've got basically maybe an account that you've bought that you can get up to 40 megabits per second. I think my account, I've got a 50 megabits max. But you'll see that you have quite a different upload to download speed. So when you're trying to upload things at home, you're trying to submit something or doing your Zoom, for example, where you're sending a lot of sound and video, that's going to potentially struggle at some of these speeds that we get in Australia. And that's why a lot of people like maybe turn off their video when the Zoom's a little bit iffy, because it means you're sending less data up into the network rather than drawing down. So the idea when all of these systems were built is that you were going to be consuming more, that is downloading more internet than you would be producing data and so on to push into the network. So On the flip side of that, if you look at the NREN, so this is the National Research and Education Network, AARNet in Australia, you'll see that it's a symmetric system. So it's built to give the same advantage, if you like, the same speed to whether you're uploading or downloading, because the assumption is that this sector is going to be creating a lot of data or knowledge, information that it's sending up into the network. So that's a big distinction. And for those of you who know your Mbps from your Gbps, you'll see that the speeds are much, much, much greater on the NREN. So here's a bit of a look just to give you a physical idea of the network. This is what it looks like. So it is definitely a physical thing. It's quite hard for us. A lot of us work with Wi-Fi now, and you kind of don't think about the network as a physical thing with tubes and things, but there it is. And you can see there that we've got an up to 100 gig transmission cable. That's the orange ones. And then there's some 10 gig ones in some of those connections that are using a little bit less data, either because there are fewer universities or a smaller population. But in general, you can see from that map that the network is put together based on where the research is happening and where data is being collected. It's not about a kind of commercial design or where the most people are. I think that's very clear. If you look up to the north of Geraldton there in Western Australia, you can see the MRO, and that's an observatory that's collecting a lot of information from space. And so we have a special network connected there to be able to get that data down and into the network so it can be shared with the rest of Australia as well as the world. So if you take that idea of a network and then put it into a global context, you can see now how different countries are connected through these national research and education networks. Some of these aren't exclusive connections. They may be shared with other telecommunications companies. But you can see in this map a little bit of how the distribution occurs, I suppose, for sharing data between different research institutions around Australia. So you can see there's quite a strong connection, and that's historical as well with the US, and then going into Asia. And you also see that, yeah, a lot of these things are actually in the sea, which I think is really fascinating. And I didn't really know that before I started working at AARNet, but there's definitely a lot of internet going under the ocean at the moment. So we now have a system that goes from Sydney to Perth and then up to Singapore, all entirely submarine cables, which I think is kind of cool. So that's AARNet connecting all of us in Australia and our various institutions to institutions across the globe. And we all work together. We're often working with the international NREN community to ensure that these connections are stable and working at their best capacity all the time. So the message there, I think, is to ensure that when you are working with your research data, that you think about when you're making your data transfer. So what I would say is if you are uploading a data set to the internet, for example, or you need to share something to do with your publications or whatever it is, you'll get the best experience by working at your university campus, even better on a networked computer that is connected by cable, but even the EduRoam system on any university campus across the world is often much better than the experience that you'll get at home, and especially the experience you get at home during the Netflix hour, if we want to call it that. There's quite a strain on the NBN, if you like, in the evening when a lot of people are drawing on their internet connection. So just be aware, if you have to work from home, it may be better to make some of these data transfers happen in the later evening or early in the morning when there are fewer people using the internet. And I've got plenty more information about networks and so on. So if anyone wants to know, please write to me and I can talk about these things for days. But now I'll move on to the platform that we have as a way to assist people to make the most of this network. So it's one thing to have it, but then it's one thing to make the most of it in terms of the types of things that you'll need to be doing with research data. So we put together this diagram, and it's putting the different tools that are available in the platform called CloudStor within the context of the research data management life cycle or research data life cycle. So that top right-hand quadrant being proposal is where you would be putting together your ideas for your new project. It might be that you need to download some data sets and have a bit of a look at them and so on. So what you might use, and it's actually the biggest orange circle, the one that covers the whole life cycle, is a tool called File Sender. And I'll take you through that. And that's a really fabulous tool for moving what we call indiscriminately large amounts of data around. And you can have people send things to you via the system, or you can send people things using the system. And it's basically agnostic to file type. You can, I think we've tested up to petabyte scale. There's quite a lot that you can do with that. And I think if there's one thing you take away from today's talk, I think we'd like it to be File Sender. You can also see in that grey semicircle only Office. This is an open source Office document suite. So it's got spreadsheets and Word documents, slides, everything that's compatible with your other providers like Microsoft and Google and so on, but you can use it within CloudStor, and you can do collaborative editing and so on with that. So if you're putting together a proposal, you might have a group folder within CloudStor and everyone can work on the same documents editing. So you've got that one authoritative version rather than perhaps emailing multiple versions and perpetuating that kind of many copies of things. You can just work on the one. In that data collection quadrant, there's a couple of probably strange sounding names for you there called Rocket, WebDAV and Sync. These are all different types of technologies to help you get data where you need it and as quickly as possible. So there's some kind of specialized systems, but if you are kind of hitting the limits of certain ways of moving data around, then definitely get in contact with us and we can help you with that. Something that your everyday researcher would definitely use is the sync, and that's a way of having your cloud storage in CloudStor updated every time you update that file or that information on your laptop. So they're mirrored in the cloud and on your laptop. So you can continue working on your laptop. You don't need to work in a new environment, but you know that you've got a mirrored copy in a different location, just in case if something happens to your laptop. The data analysis side is where we'll be kind of hitting a lot of points today. I suppose we're going to be looking at Jupyter Notebooks, and that's that SWAN. It's a big grey circle, semicircle on the left, and that's that service for web-based analysis. And effectively what that offers you is the ability to do coding in the cloud. So if you feel like your laptop is really slow, if you're starting to use code and it's kind of getting hot or making funny noises, then it might be time to think about doing that coding in the cloud, where you can kind of set it and forget it, use a shared resource that's going to be a lot more generous than your laptop. And on the last one there in the publish, there's something called collections, and that helps you package up data so that you've got the necessary metadata wrapped around those data sets before you send them off to a repository, which is not exactly the final part of a research project. Often they'll keep feeding into each other, these separate activities, but it's a good way to make sure that you're protecting the information that pertains to the data if you maybe not going to look at it for a little while. So for those who are interested in CloudStor and what you can, what we offer, I suppose, any individual researcher in Australia and New Zealand gets a terabyte of free storage to use. And you can also use what we call group storage. So that's when you can have a multitude of people all working in the same environment. And it doesn't matter if they're from the same institution, different institutions, or even external to the university system. They are, the way that CloudStor has been created is to be able to kind of smooth out any of those differences between institutions and you know, different login systems and all of that. So it's just a way, it's a great way for collaborating across different institutions and with industry. So file sender, which is what I was talking about before, is that quick and secure file transfer with no file size restrictions. I think that will be music to a few people's ears. If you've started to have a few problems with the size of your data sets, then that is a really fantastic tool, and it is quite simple to use. It's all has a web interface, so you don't really need to install anything or anything like that. You just, I'll show you, go onto the website and then you log in using your university credentials. I'll talk a little bit more about Jupyter Notebooks, and I'll actually introduce that concept. So if you're wondering at this point what Jupyter Notebooks are, stay tuned, I will explain in my own not technical way. And for those of you who are really concerned about data sovereignty, and you may have grants and things like that that might require you to be very careful about your data transfer, if you have sensitive data, for example, we can assure you that the storage is located in Australia and directly connected to us and backed up in all of the right ways and all that sort of stuff. So what you're getting is something that is going to be connected to this research network, so that very fast internet, and you avoid any sovereignty issues in terms of where your data is being held. And it is a sustainable service that we plan to provide indefinitely. So hopefully that will give you some reassurance. So just to give you a little quick look, and then I'll go in and do a bit of a live demo, but I've got some screenshots here. The storage of your data, it's a very similar idea to Google Drive or the Microsoft or Dropbox or any of those. So you've got a list of your files, you can create your directories, any structure that you like. You can share these items and control the levels at which you share the items. And like I said before, you've got a terabyte to play with. You know, fair amount for a lot of researchers anyway. File sender is this other tool that I was talking about, which is your ability to share large data internally and externally via file sender. And on the left there, you can see something called vouchers. And that's a really important little concept to get, because what you're doing there is actually you can send a voucher to someone. So they may be working externally to university systems, so may not have access to CloudStor themselves, but you can send them a voucher so that they can access the system. So if you're expecting a data set from an external provider and it's a very large one, then I would recommend this system. They can then upload it and it will be on the AARNet system ready for you to download. And that can be a secure, encrypted end-to-end connection. So it is sufficient for sensitive data. I mentioned before only Office. So this is the ability to do collaborative document editing. So you can have multiple people working on a document at the same time. Again, a lot of people are familiar with Google Drive and Google Docs, so it's that similar idea. We've got the spreadsheets and the slides and the Word document. You can also access CSV, for example, and a few other bits and pieces that might be more pertinent to researchers rather than a general user. So we do try and ensure that the plugins and the types of things that you can do with these documents are very research oriented. I think we've got a link in there to Mendeley, for example, if anyone uses that. And for your data analysis, this is the system where you can do your coding in the cloud in these things called Jupyter Notebooks. And this is another tool within CloudStor. So if you're in your CloudStor environment, you can click on the little SWAN icon and that will open up this computational environment and where you're using the cloud computing area, the cloud compute area. So that's just basically doing computing on someone else's computer, but that's our computer. It's the AARNet computer. And like I said, it's a bit more generous, or probably a lot more generous than most people's laptops. So it could be an idea for you to think about if you're revving up your laptop and you want to get into a bit more kind of bulky analysis. So are there any questions or anything you want to know at this point, audience? Or shall I continue?
I think we can address any questions in the Q&A, if that's okay.
Yeah, sure, no problem. Well, I will carry on. Can you still see my share screen?
Yeah, perfect.
Oh, good. All right. So at this point, we'll just have a little change of gear, and I just want to go through what are we talking about when we're talking about Jupyter Notebooks, because I'm aware that some people listening might not have heard of these before. So I have my kind of non-technical way of explaining these things. And once you've listened to this, if you're interested, there is a ton of information on the internet. What I've found, though, is a lot of the intro to Jupyter Notebooks is for people who are already quite competent in programming and coding and come from that kind of background. So for people who are coming, yeah.
Very quick, we see like the slide is overlaid by a picture of me a little bit.
Yeah, I can see that. Sorry, that's the.
No worries. I just want to let you know.
Yeah, thank you. That's great. So what are we talking about when we talk about Jupyter Notebooks? So in a nutshell, like if I've got 5 words or less or whatever it is, Jupyter Notebooks are a data analysis tool. So they do come from a kind of computational sciencey background, but they are being used in a load of different environments and for different disciplines and different activities. So what they allow you to do is do coding in the cloud. And I've broken that down for those who are real beginners, that it's using computer programming languages to do computational work on someone else's computer via the internet. And the advantages, again, is that you're not using up your space in your laptop. You also don't need to download and install a bunch of things on your laptop. What you need is an internet connection, and that's it. So what do they look like, or what is it? Notebooks or notebook interfaces are not a new technology. In fact, I think they've been around since the 80s. And it's essentially a kind of like an advanced word processor. So I've got a picture on the left of the word processor that a lot of us are quite familiar with. But what you get is it gets kind of a superpower where you can also use the command line type idea. And that's that black box that's often a little bit kind of foreboding for people who haven't been involved in computer science for a long time. But what you get is the power of being able to use computer code in an environment that allows you to explain what you're doing and display the outputs of that code. So if you want to create a visualization, for example, you want to tinker with it, see what happens when you move certain things, you can do that all live in the same place. So you're not using a command line, you're using a fairly friendly looking environment where you can have explanations, headings, you can put videos in there and images and all sorts of stuff. Pretty cool. So the people who make Jupyter Notebooks talk about them in this way. They say Jupyter Notebooks is a free, open source, interactive web tool which researchers use so they can combine software code, computational output, explanatory text, and multimedia resources in a single document. So it's quite a powerful tool. So just highlighting there that they're freely available. And this is really the crux of it in terms of their usefulness in a research environment, because they will allow reproducibility. And we can talk a little bit more about that later. But the fact is that you're not using sort of proprietary programs that may not show all of the code that is being used. And if you don't have very good understanding of how that program works, you may not be able to reproduce or fully explain the results. I talk about them being super flexible. You can, in fact, email them to people and you can upload them and download them and store them on various sites and use them in a whole range of different environments. You don't need to just use them in our environment. There are lots of different environments that host Jupyter Notebooks. So they're quite a good tool for communicating research and sharing ideas and results with people. I did put in there, they help you save time. I'll add a caveat there that if you don't code, obviously you'll need to kind of get your head around some programming concepts. There may be an initial investment in time in learning how to adapt what you're doing into a computational method. But one thing that they're great at, like all machines, is that they're really good at doing the machine stuff. So that may allow you to get on and do the things that humans are really good at, and you can get the computer to do the things that may be a little bit repetitive and stuff that could be automated. So it's something to think about. So what do they look like? This is just a basic example to show you that the interface is not dissimilar to Word. You've got those those little menus at the top, like File and Edit, View. You can see some scissors for cut and then 2 pages for copy and so on. So there's some familiar commands and things in there. You can see the heading and the text, but what you've got is that little grey box that's called a cell, and that's where you put the computer code, and that is where the computer that you're running it on will actually understand that that's not standard text, that's code, and it will be able to read that code and be able to create the output that you request using that code. So for example, with this one, you can see at the bottom, there's a little data set that's being displayed, and the code above has said, I want to have a look at this data set, and it will bring in and have a look so you can see it, and then you'll be able to work on that data set using computational methods. And just briefly, what is going on in there is that you have this great ability to have a human readable document. So this is where you can communicate what you're doing with this code using text. You can use images, figures, tables. Like I said, you can pop a video in there. So you can still communicate to people who don't understand code or use any of those methods, but you also have that computer readable aspect. So you can use this code that will work and run and perform all of those calculations, create visualizations, and do the computational grunt work that you may not be able to do, or it just might be quicker to do this way. So again, that's really one of the keys to the popularity, is that you've got this combination of things, and that ability to communicate then helps with that reproducibility concept. So whatever you're doing, if you're explaining it in a certain way and you're exposing the code, anyone else should be able to come along and reproduce and understand how you get to those results. So that's the end of the presentation. What I can do now is I'll just stop sharing for a sec, and then I'll close that off, and we'll do a little bit of a live demo. I'm feeling dangerous. Hopefully it works. And I'll show you a little bit of how to get into CloudStor, do a quick demo, and a little bit of the power of what you can do. And we'll have a look at a text analysis notebook, so you can kind of get a sense of where you might get to creating Jupyter Notebooks. So if you've never used CloudStor before, you can go to our website. You can see that it's the website, can't you? Not just showing you back your own faces.
Yeah, we can see it. It's all right.
Excellent, thank you. So it's aarnet.edu.au, and you'll see there's a load of information. Please go and have a look. It's quite interesting. But where I'll point you to is the login and tools. They're on the top right-hand side of the screen. So you click on login and tools. That opens up another little banner underneath. And from there, you can select CloudStor. So selecting CloudStor, you'll get to this new user page. And you can see here the list of institutions that are part of that CloudStor network. So you can scroll down and look for yours. So for example, the University of Queensland is there. You can also search by name, and you can see there's New Zealand as well. And what you'll do is click on your institutional login, and that will take you to the AAF login. So that's the Australian Authentication Federation. And you use your normal institutional login that you have. So yay for CloudStor not making you have a new password. I think that's also very excellent. If, however, you are working with people who are not on that list, but you have requested them to be added as collaborators to your project, you can actually have them added by your local admin. And what you'll direct those collaborators to is this CloudStor hosted virtual account. And that's where they'll log in. And through that process of requesting a collaborator to be added to a group, they will get the instructions on what their login and password will be. So just be aware of that there is that capacity to add external collaborators if they are not part of this original group. So that's logging into CloudStor, and I'll take you now to where I've logged in. So when you first log in, you can see there's this little house there. That's your home area, and we're under the tab of files. So this is your storage area. And you can see on the left, there's different ways of looking at what you have access to in this storage environment. So at the moment, I've clicked on all files, and that will be my entire stuff in my system. You can favorite things, and this is important here, shared with you. So if someone who has built something or has made something, or if you're part of a group, but it's not in your personal storage, you'll be able to see it in that shared with you menu. So you click on that and you'll be able to see all of the things that you have access to, but they're not actually part of your personal account. For those of you who were wondering where your Zoom recordings go, if you've recorded them on the cloud, they end up here. Most importantly, if you have a panic and you can't find something, the deleted files button is down on the bottom, and things will stay in there for about 30 days, and you can click on restore and they'll go back to wherever it was that you accidentally deleted them from. So that's a nice little one to remember. And I'll also point you to that big Riddler question mark there on the top right there. That will actually open up a new page there. So you can have that open at the same time as you're learning. And that's got our CloudStor knowledge base. So that's all of the different questions that might come up as you're starting to get your head around CloudStor. And you can see there's quite a lot of information there, divided up by the kind of tool, the different tool that you are accessing. So remember that deleted files down at the bottom and help at the top right. I've put together a sample research folder just to show you what you could do if you were collaborating. I've put together proposal, admin, data analysis, publications and archive, a little bit like that research data lifecycle. And then you can populate that as you wish. I've got a little bit of data in here to show you. This is kind of a mock COVID-19, seeing that was something fairly all-encompassing for all of us in the last year or so. But you can see here, for example, I've got a video in there. If I click on that, you can actually play the video within CloudStor. You don't have to you don't have to download it again. So if you are sharing something with someone, you can actually just point them to wherever it is and they don't have to download it. So that's quite handy if you're working with large files and so on. So we've got some MP3 in there. That might be an important file type for people working in language. So you'll be able to see this in the full file. But if, for example, you did want to just bring to the surface, so wherever your stuff is in different folder structures, if you click on the audio tab at the top of your CloudStor storage area, what that does is actually bring up all of the audio that you have in the system. So you can see there, you can organize albums and tracks, and you can create playlists. So anyone who's working with audio, that might be of interest to you. So just going back to files to show you how you might share something, because this is one of the really powerful things about CloudStor, is you can see you've got this kind of universal share icon there on the right there. So if I click on that, that will open up a panel on the right, giving you various options for how you might like to share that. So that's actually a whole folder. And let's say I want to give access access to that folder to one of my colleagues. I can add the email address of that person there. I'll just see if I can remember somebody's email address. Here you actually have to type out the full email. Oh, that has, here we are. Oh no, that's, yay for a live demo. Hang on, I'll try another one of my colleagues. Here we are, see if that works. This is not an autocomplete, okay? So you actually do need to remember or copy and paste an email. That's done to protect everyone. The benefit of CloudStor is that it's really easy to share with anyone, but that does mean that it's really easy to accidentally share things. So we do try to make it as less possible to make mistakes. So make sure you've got that full email address there if you want to share it. So you would click on that CloudStor user, and then you've got an ability to share at certain levels. So you can see here, I've got that little arrow down there. I can deselect any of these to be able to determine exactly how much access and how much control this other person has on my file. So for example, I might not want to give Ryan access to be able to delete anything. So I'll remove that, and then I can notify him by email. He'll get an automatically generated email, and then he'll be able to see that folder in his shared with you area. If you want to remove that access, you can at any point by clicking on that bin icon, the trash one there, and I can just remove access to that, and it's all done. He doesn't have access to that anymore. So it's quite easy to share, but it's also quite easy to remove that access. If you've got public information that you don't mind sharing, you just need to be aware, is it okay to share this publicly? You can actually make a link. This is handy if you don't have anyone's email address, you want to put it on Twitter or share it in a Slack channel. You can create a link using that public link button. And you can then also change the amount of ability people have to access that material. So you can have it just as a download and view. You could create a folder that has things in it that people can download and view, but they can also upload and share things into. Or you can actually just create an empty folder and allow people to put things in it. And that's quite useful for lecturers and people who want to have things submitted to them. So you can give people access. You can control it a little bit by adding a password and expiry date. You can send directly via email from here. Otherwise, you can just create the link, click on share, and then you can copy that using the copy to clipboard there. So that's one of the handy things about CloudStor, but I'd like to take you now to File Sender quickly and show you that. And then we can go to the Jupyter Notebooks. So logging into File Sender, what you'll see here is the ability to drag and drop your files. You can have a whole directory if you like. And then once you've uploaded anything it is that you want to share, then you pop in somebody's email address, subject, whatever message it is. You can put an expiry date. If you don't have an email address, you can get a link instead. And here, importantly, if you have sensitive data, you click on that file encryption button and you'll be able to generate a password. Really importantly, though, if you are doing this, don't share the password in that message. You need to make sure that you share the password in a different channel. Otherwise, it wouldn't be deemed encrypted and secure. So just be careful with that. And I mentioned as well the vouchers on the left there. That is allowing you to have someone send you a file. So you can create an email that will have a link in it. It will send them the instructions and they can upload whatever it is that they want to share with you via that link. You can get quite a lot of information about your transfers. If you click on the links here, You can see, for example, I've sent some here. You've got an ID, some little bit of data about it, and you can also see the transfer log. So this is quite important. If you are making a sensitive data transfer, you may want to keep that log so you can send that to your email, and you'll be able to see exactly what IP address downloaded or uploaded at what time and so on. Okay, and don't forget, press on the help if you need help or let us know. So that's a file sender in a nutshell. But now what I'd like to do is actually take you to what we call SWAN. So you can see a Jupyter Notebook in the context of language and linguistics. And this is a notebook that has been made as part of the developments in the Australian Text Analytics platform, which is ATAP. And AARNet is a really proud partner of that project. And we're really happy to be helping and providing some of the technical gear and the backbone to what is a pretty exciting development in this area. So looking at this notebook, what I've done is I clicked on the SWAN. So that's the service for web-based analysis. So you're using the internet, someone else's computer, to do your code and analyze your data. So this notebook, you can see it's got the heading, it's telling you what it's for. So we're looking at Hansard, the record of what's happening in Parliament. And that's quite a big data set. So trying to do that on your own reading would take quite a long time. But now there's quite a lot of good technology to be able to do this automagically, as some people say. I mean, obviously there's a little know-how that you need to put behind it, but what you get here is a demonstration of some of the skills that you will be able to learn and use as part of the development of this Australian text analytics platform. So this one here is a skill level for a beginner. We're going to look at some simple data wrangling. Wrangling is a really good all-encompassing word. I love it. It just means like all of the hassle, basically, all of the problems with data. There's a lot to deal with before you can get to the good stuff. So hopefully we can make that a bit easier. We'll be looking at word frequency counts and then visualization or representation of that data and some normalization. So what you see here is this quite nice way of communicating what you're doing. So you can use colors and little boxes and notes, and you can pop in links, for example. You can see here, that's going to point you to another notebook. So as we go, we'll be developing more and more of these. But here you can see these text, nice little interesting points. And then this gray box, that's your cell. So that's the one with the code in it. And one of the things we're hoping, and what I work towards a lot, is that you'll be able to, even as a non-coder, approach Jupyter Notebooks with an ability to stay calm in the presence of code. So you can kind of look at it and go, oh, there's some code there, but not particularly get too caught up about it. You don't need to learn code from scratch and then know it off by heart, like if you were studying French or whatever. A lot of the approach now is about kind of getting a little bit more comfortable, understanding what types of things the code can do. And you would do that by reading and looking at more and more notebooks. And then over time, you might be able to adjust and tinker with the code, and eventually you might be able to adopt and write some of your own code. But it's definitely a phased process. So this one here, we're reading in some data, and then we're going to print it, but we just want to find out about what Adam Bant's been up to. So this is the verbatim transcript, and we're going to pull that out, and then it's going to do some kind of computery looking thing. But you can see in here, there's actually the text. So this is what Adam Bant's been talking about. It's got a whole lot of information about it. We can kind of glaze over that. There's quite a lot of it. That thankfully the computer took care of. We didn't go through with a highlighter or anything. And then you can tell I did my PhD well before any of this technology. And then the next, we're going to have a look at Katie Allen. So we're going to compare these two politicians and what they're up to. So again, loads of text, little different bits of information that are coming out of the Hansard. And then here's your data wrangling. So we need to have this data structured in a way that the computer will be able to do what it needs to do. And then we'll print it out again in little different ways. Keep going, bit more. I think this is where Simon probably has a better way of explaining what's going on. But we're getting to a point where we can start to count how many of which words are coming up. And this might be very pertinent to people's studies in language and linguistics. So, for example, how many words are in a sentence, how long are the sentences, what words come with other words, and so on. So you can use certain packages to get this to work. One of them is called NLTK, which is Natural Language Toolkit, I believe. And you can draw on other people's programming. There's other what they call packages. So you don't have to build things from scratch. You can download these special things here that will help you do things more quickly and get to the end point that you want to go to. So we're turning this list of snippets into a single chunk of text, and then we're going to turn those tokens into normalized forms. And you start to see these little words that are coming out that are quite common. And by the end, you get this lovely little visualization that you can copy and then paste into a report or put on your blog or whatever you're doing. But you'll be able to see here the 20 most frequent words that BANT has been using. And you're not surprised, I guess, to see words like climate and coal, gas, and so on. Whereas on the other side of the room, you've got more talk about the Prime Minister, the economy, Morrison, and so on. So the interesting thing here is you've got this ability in this system. So when we start publishing these notebooks, where you can then muck around with that. And so you've got an invitation here to limit it to the top 10, or you could limit it to the top 30, and use this as a learning opportunity to see what you can do with CloudStor. So that's me, I think. I think I'm done. Is that too early? Is it time to have a bit of discussion and talk about other things? I've got a few articles and stuff that I can show you and keep going, but I'm kind of happy to open it up to the floor.
Yeah, okay, we can open it up. Just let me say thank you so much for the wonderful presentation, and I'll stop the recording here.